Bismillahirrahmanirrahim. My name is Muhammad Hammad and I am from the Chemistry department. Today my presentation topic is semiconductor and its application. Now first of all I tell you about what is semiconductor. A material that has an electrical conductivity intermediate between that of conductor and that of insulator called semiconductor. So semiconductor conduct electricity less than conductor, but they can conduct electricity more than insulator. And what is the conductor? The substance which have ability to conduct electricity are called conductor, and the substance which resist electricity called insulator. So semiconductor lie between conductor and insulator because their conduction intermediate between them. Silicon and germanium are the major example of the semiconductor. Now, first of all, I tell you about bonding. Diamond atom is the bonded tetrahedral. A carbon atom is bonded tetrahedral to other four carbon atoms. So they form a sp3 hybridization when valence orbit of carbon 2s and 2p combine to give bonding and anti-bonding molecular orbitals. Bonding molecular orbitals have low energy and anti-molecular orbitals have high energy. Now I can explain these information in other slide. Valence bond. Low energy bonding molecular orbits are called valence bond. Conduction band. Sorry, valence band. Low energy bonding molecules orbits are called valence band. Conduction band, high energy anti-bonding molecular orbits are called conduction band. And band gap, the gap between valence and conduction band are called band gap. The band gap in diamond is about 520 kilojoule per mole. Now, as we know that the carbon have 6 electrons, so these are the 2 electrons in the innermost shell and they contain 4 electrons in the outermost shell. In the outermost shell, the 2s and 2p subshells are involved. So that is right on this. By the combination of 2s and 2p, they form a bonding and anti-bonding molecular orbits. So this is the MOT of valence bond. 2s and these are the 2p. 2p, so they contain our two bonds. By the combination of these bonds, they form these are called low energy molecular orbitals and these are called high energy molecular orbitals. So firstly, the electron occupy the low energy molecular orbitals. So these are called the valence band and these are the conduction band. So in conduction band, as we know that they do not contain any electron. By this way, the diamonds are the bad conductor of heat and electricity because they have no electron for the conduction. In diamond, carbon have only 4 valence electrons. As we know, as I write a structure of the carbon, they contain our outermost 4 electrons. So the carbon have only 4 valence electrons. The valence bond is filled and the conduction band is completely empty. So in this MOT, we observe that the valence band is filled, but the conduction band is completely empty. Due to the emptiness of the valence band, they do not conduct electricity. In insulator, there is a huge band gap. So what is band gap? In the previous slide, I tell you about the gap between valence and conduction band. So the gap between valence and conduction band are called band gap. In insulator, there is a huge band gap as you can observe in this diagram. This one is an insulator, this one is a semiconductor, and this one is a metal or conductor. In insulator, there is a huge band gap due to the large size of band gap. They cannot conduct electricity. But in semiconductor, this band gap is very small. So by applying a small amount of energy, they show the conduction. And in metal, the conduction band and valence band are overlapped. By this way, they can conduct electricity very well. Semiconductor and an electron. potential and an electric potential is applied to semiconductor, it conducts small amount of current because the potential can accelerate or jump the electron from low energy to high energy band. As we know that they have a small energy gap between the valence and conduction band. So when we apply a small amount of energy, if by this way the electron of the valence band move to the conduction band. By this way, the conduction band is partially filled and the valence band is partially empty. So they can conduct electricity. Conductivity. The electrical conductivity depends upon the temperature. As the temperature increases, the conductivity of semiconductor increase. As the temperature increases, the conductivity of matter decrease. So, what is the reason between that? In semiconductor, when we supply our electricity or we supply our temperature, the conductivity of semiconductor conductor increase. The reason of this question is that because the temperature, the electron move toward the conduction band. In previous slide, when we apply the temperature, the electron move from valence to conduction band. By this way, the conductivity of the semiconductor increase. But in metal, when we apply the temperature to the conduction to the conductor, the electron present in this atom they bound it because when we supply the temperature, the atom start to vibrate due to the vibrational motion of the atom. The electron which is present in them, they they cannot any space for their movement. That's why they show less conductivity by increasing of the temperature. Doping. What is doping? The addition of small amount of impurity in semiconductor is called doping. By adding, they are made two way. By we can dope the semiconductor by two ways: by adding 5A element or by adding 3A element. So N-type semiconductor. N-type semiconductor is the example in which we take a five, in which we dope the semiconductor with 5A element. When semiconductors such as silicon we dope with 5A element is called N-type semiconductor. As we know that silicon also belong to the 4A group, so they also form a 4 bond with them. So they form a tetrahedral structure. So when phosphorus is doped, then the electron occupy the conduction band because the phosphorus atom has 5 valence electron and therefore induce an extra electron. So n-type semiconductor is also called negative semiconductor because the P have ability to P belong to the or phosphorus belong to the 5A group, so they have 5 electron in their outermost shell. They use 4 electron for bonding with silicon, but they have only 1 electron which cannot further bond with the other silicon. By this way, these electron is ready to move. So due to the presence of this free electron is called n-type semiconductor or negative type semiconductor. P-type semiconductor. When a semiconductor such as silicon doped with 3A element like boron is called p-type semiconductor. As we know that boron belong to the 3A element, so they have a 3 electron. They have 3 valence electrons. So the boron use these 3 electrons for bonding with silicon. So the hole is empty. So hole is available for the electron. That's why due to the presence of this hole is called p-type semiconductor and P stands for positive. So this type of semiconductor is called positive type semiconductor. Now I can explain all these semiconductor and doped semiconductor. So this one is a pure semiconductor which have a silicon atom which are made up of only silicon atom. When we dope the semiconductors with 5A group like phosphorus, so this type of semiconductor is called negative type of semiconductor because phosphorus belong to 5A group. They use 4 electron for their bonding and 1 electron is remaining. So due to the presence of this free electron is called n-type semiconductor. And this one is p-type semiconductor due to the presence of 3a element like boron. So when boron is available, they have 3 electrons in the outermost shell. So these 3 electrons are involved in bonding, and they create a hole because this silicon cannot bond with this boron. By this way, the hole is present. So this hole is called positive. So this hole carry a positive charge. By this way, this type of semiconductor is called positive type of semiconductor. Uh, uh, you can easily observe that in this semiconductor, in p-type and n-type semiconductor, due to the presence of an electron, the conduction band is filled. But in p-type semiconductor, the valence band is empty. By this way, they can conduct electricity. Now I tell you about its application. The semiconductor are used in many devices like diode. It is also used in light emitting diode, LED diode, laser, photovoltaic cell, and a transistor. Now I tell you about this diode. The diode is a device that permits electric current to flow in one direction. With the help of diode, convert we can convert the direction of a random direction of a current into a single direction. It consists of p-n junction. What is p-n junction? When p-type and n-type semiconductor are combined, then p-n junction is formed. If n-type semiconductor is connected with the positive terminal of the battery, and the p-type semiconductor is connected with oh sorry, when n-type semiconductor, this show the n-type semiconductor and this one show the p-type semiconductor. When n-type semiconductor connect with negative terminal of the battery and the p-type semiconductor connect with the positive terminal of the battery, the electron in the conduction band of n-type repel by the negative terminal and attract to the positive terminal. So this one is a p-type semiconductor and this one is an n-type semiconductor. The electron move in the region of p-n junction from n-type to p-type. This one is a p-n junction. By the creating of p-n junction, when p and n-type combine, so the p-type move to the holes which are present in p-type start to move toward the n-type, and the electron which is present in n-type move toward the p-type. By this way, the region is formed is called depletion region or is called p-n junction region. So in this region, the neutral atom is formed. There is no free electrons or holes available. Okay, if we reverse the connection, if we as we know that when we connect its positive terminal and in this it is connect with negative terminal of the battery, so the negative repel each other and the positive repel each other. By this way, they start to attraction to they start to attraction, so the positive start to move and the n type start to move p type, and this is called forward bias p-n junction. If we reverse the connection and the p-type semiconductor connects with negative terminal and the n-type semiconductor connects with positive terminal of the battery, so both are opposite in charge, so they show the attraction to each other and there is no the conduction of electrons. By this way, the electron cannot be conduct in reverse bias in reverse bias. So p-n junction also act as a rectifier. Rectifier is that which can convert the AC voltage into a DC. So here I can also explain it again. In first slide, in first diagram, the p-type semiconductor connect with positive terminal and the n-type semiconductor connect with negative terminal. So these are like charges. Both these are like charges. By this way, they can repel each other and they show the attraction with each other. And this is called forward bias and this is called forward bias junction. And in this diagram, the positive, the p-type semiconductor connect with negative type, so these carry a opposite charge. Due to the presence of opposite charge, the positive move to the negative. And in this part, the n-type semiconductor connect with the positive. So these are oppositely charged. So the electron start to move the positive terminal of the battery. So in this region, there is no current to pass through it. By this way, we can rectify the AC current into the DC current. Photovoltaic cell. The cell which have ability to convert solar energy into electrical energy is called solar cell or photovoltaic cell. When light with energy greater than or equal to the band depth shine on a PN junction, excited the electron from the valence band to conduction band. By this, current is produced. The resulting current can be stored to charge a battery. Now I can explain it with the help of diagram. So, in this way, the n-type and p-type semiconductor, when n-type p-type semiconductor are combined, the PN junction is formed. So, in this, we apply a sunlight by the application of the sunlight or photoelectron are applied to the semiconductor. The neutral atoms which are present in the PN junction and they absorb the photons from the sunlight and break into the positive and negative ions. So these negative ions start to move by this way. If the battery is attached to this terminal, so the battery start to charging. Or if we attach a bulb with this terminal, so the bulb start to glow. By this way, the solar cell is work. Diode laser. The word laser is an acronym for light amplification by stimulated emission of radiation. So in this way, when the PN junction when a PN junction is connected with the positive terminal of the battery, so they produce a light. This is called the diode laser. The diode laser produce light as a result of combination of electrons and holes in the region of PN junction. So it is also used in laser printer, barcode scanners, which we can easily observe on a shop. So these are the PN junction. When N-type connect with negative and the P-type connect with positive, so this PN junction is formed. So these PN junction carry the charges, so they can split and produce a photon of light. So these photon of light can be easily observed, and with the help of this same process is used in the laser printer barcode reader scanners. Thanks. This is from my side. I hope so you can understand all the points. If you have any question or query, you can ask me in comment section.